I'm Chris. I'm the CTO, one of the co-founders at Huntress. I do a bunch of stuff. I write a lot of code. I've handed off a lot of other responsibilities so that I can write code, right? So I don't manage a big team. I've got a team of like 6 people who report to me. And that gives me the space to try new things like ClickHouse, building new products, all that kind of stuff. So Huntress, we founded in 2015. We do security for mid-sized enterprises and SMB. But secretly, we're a big data company. We have a ton of data. That is how we do security. So I should have put some numbers in here. I didn't. We manage just over 3 million endpoints. We collect data from Microsoft 365 on a little over 1 million identities. And we're collecting logs, SIM data from like 500,000, data sources. So pretty large amount of data. So anybody heard of a SIM before? SIEM, some people call it. We call it SIM. So it stands for Security Information and Event Management. Basically what that means is you as a security team want to pump a bunch of data in there, logs, activity data, all kinds of stuff, so that if there's an incident, you can go back and look at it. Ideally, the SIM will also help you identify bad stuff that has happened so that you can query it and see what's in there. But it's kind of like centralized log aggregation. So if you've ever used a log aggregator and like writing application, you write logs, they go to some centralized place. SIM is a lot like that with some extra stuff on top. A lot of times you'll see it paired with what's called SOAR, which is kind of gives you the orchestration and automation. So if you find something bad, how do you do stuff like lock somebody's account or isolate a machine from the network, et cetera, et cetera. So the data that goes into SIM, there's a variety of sources. So like things like network infrastructure, we pull data from like a bunch of identity providers. We pull things from like AWS and Google Cloud. And it comes in all kinds of different formats, like syslog. Anybody ever heard of syslog before? Yeah, it's like old, terrible format. Yeah, horrible. JSON, which is good, but then it gets real bad from there. We get stuff that's just like text and other formats that like you have no idea what it is. Some of the formats are just like comma separated values, but they don't have any headers. So guess what field is what? It's a fun game we like to play. So we have to write parsers for each of these. So we have to figure out like what is the data source, what are the fields, what do each of these mean? We have to write a parser to break it out and put it into some sort of schema. So there's a couple of these that are common. One is the Open Cybersecurity Schema Framework. This is a newer one. AWS has come out with this, as well as a bunch of other people. Elastic Common Schema is probably familiar to people who have worked with Elasticsearch before. And then there's other stuff that's just like vendor specific. But the goal of this is, how do I take data that's in all kinds of different formats and abstract stuff that I care about? Think about usernames, email addresses, phone numbers, IP addresses, so that I can query across all kinds of different data sets, right? If something happens from some IP address and it's malicious, I want to be able to query on that IP address and see what else did they do? What other systems did they touch? If a user calls me and says, hey, I clicked on a phishing email, I want to be able to pull up that user's email and see all the different places that they've logged in, all the different things that they've done, right? So that's the intent of parsing all of this data. There's some challenges though with SIM. Obviously, off the bat, you can see there's a ton of data. We've got to collect it from a bunch of different places. We've got to process it. We've got to store it and index it. And more data usually means higher cost, right? You got to pay to process it, you got to pay to store it. So some portion of the data needs to be searchable. Most SIMs, you will not be able to search back through all of the data. There's some people trying some new things with things like Iceberg. People have tried like Athena on S3. Works great, but if you query lots of data, it gets really expensive really quickly. Some of it you got to keep for a long time. We're talking years. Some people will have compliance things where they'll say, hey, I need to save my data for 7 years. So that's pretty significant. Like we talked about before, the formats are all over the place. And getting test data is hard. So customers will come to you and say like, hey, I need you to create this integration with this new thing. And you're like, Okay, what's the data look like? Like, how do I get some? How do I connect to that? Right. So it's a challenge every time just to figure out what the heck you're supposed to do. And then layer on to that some of the challenges that we have at Huntress because of the products that we sell and how we sell them. So everything we sell is a managed product. So our partners are people who don't have security. They're coming to us saying, "Hey, can you provide security for me?" So a lot of our customers are going to be people who at the company they've got an IT team, couple of people probably don't have a security team, but maybe they have one person who got security plus, and that's like the security guy. And so they're looking to us to say like, hey, can you watch my data? Can you provide 24/7? Can you do all these things? So we have to manage all of it. And because of who we sell to, it's got to be cost effective, right? As a Fortune 1000, Fortune 2000, they spend a lot of money on security. They got big budgets, they can spend money on it. The people we are selling to don't have that money. So they don't have big budgets, they don't have security teams, and yet they need a lot of the same things. So there's got to be a trade-off there somewhere. So that's our job, is to figure out how the heck to do it. The goal for this was to ship a product in 6 to 8 months, which was difficult. A lot of people said it couldn't be done. We did it anyway. So we looked at a bunch of things. Elasticsearch, right? Other people talked about it. The problem that we ran into was that it's super expensive. So we have this already. We push like 16 billion events a day into it. It's very expensive. I think we pay like 70 grand a month for it. We run a very similar sized workflow on ClickHouse Cloud. I think we pay 5 grand a month. So a little different. We looked at Postgres. We've used Postgres before. We actually store a lot of stuff in there. The problem there is if you want to scale it, you got to have multiple individual Postgres databases. Like one Postgres database, even on the largest hardware you can get in AWS, only goes so far. There are internal locks that have to do with all the database ACID compliance stuff that you actually end up start hitting, and you can't go any further. We looked at Microsoft Sentinel, which is Microsoft SIEM. So we kind of thought like, hey, could we build our SIEM and our management on top of somebody else's SIEM? Maybe they've already solved the hard problems. Sort of, but it's really expensive. And I think the biggest one for us is like, how would we differentiate? Anybody else could just come and do the same thing we did, right? They built on top of Microsoft. They collect the data. How are we any different? So wasn't a good one for us. It just so happened that like right around the same time, ClickHouse Cloud was gaining a lot of popularity. We actually just jumped into that. The best parts about it is like zero maintenance. We just ingest a ton of data into there. Like people talked about before, materialized aggregations. And like I said, it's way cheaper. So works out great for us, checks all the boxes. Our setup is significantly more simple than a lot of people's. Definitely leaving some things off of here, but it is not the crazy diagram that it could be. We like to keep things simple. Simple generally means more like cheaper and more reliable, right? Like it's fewer parts that could go wrong. So we are a big Ruby on Rails shop. Anybody else? Ruby on Rails? Dang. Okay. All right. Wow. Interesting. Okay. So yeah, no, we do it a lot. A lot of the biggest companies that we looked at, like Shopify and a bunch of others, are using it. GitHub. So we figured it must be good. So we've been doing that for like 9 years. We actually use a tool called Vector by Datadog. Anybody ever heard of Vector? Yeah, a couple of people. So Vector is great. It allows us to do a ton of batching. So we basically throw a bunch of stuff at Vector, it batches it up, and it does really big inserts into ClickHouse. So one of the things you'll learn as you try to scale ClickHouse is it likes very large inserts, right? Which is the opposite of a lot of stuff, right? With Postgres, you can do batch inserts, you can put a bunch of stuff in there, but it will choke on them very quickly. However, we throw 100,000, 200,000 records a second at Vector, and it handles all of it. ClickHouse doesn't bat an eye, so good to go. So Vector, like I said, it's pretty cool. It's actually like a piece of software that allows you to connect a bunch of stuff. So it has these two concepts of sources and sinks. Sources are where the data comes from. Sink is where you want to send it. They've got a bunch of different types, and there's some really interesting stuff that you can do with their vector remapping language, where you can change stuff around, adjust the format, parse things out, like change columns, change their names, all kinds of stuff, aggregate stuff. You can sample data. It's a super useful tool. I don't know for sure, but what I've heard is that they use it significantly within Datadog. So pretty cool. We actually use HTTP as our insert source, and then obviously our sink is ClickHouse. So pro tip, there's some really cool stuff you can do with it. They actually have this like templating language. It's kind of like Mustache, if anybody has used that. So you can do something like this, and you basically can throw stuff at one single vector queue, and it will figure out what ClickHouse table it needs to go in. So you don't have to keep setting up more and more vector stuff. So that one is pretty cool. That one's helped us. So how much data do we have? So you can see this graph actually starts in February. This is when we launched. We've got about 3 petabytes now. Not all of this is in ClickHouse. A lot of this is actually in S3. So a lot of people, you know, they try to like say like, oh, yeah, I got the biggest ClickHouse cluster. We're actually kind of the opposite. We actually try to talk about how much we can do with how little we have. So I was just looking earlier. Out of 3 petabytes that's in cold storage in S3, we've only got about 17 terabytes in ClickHouse. So we do a lot of filtering, a lot of like data manipulation that allows us to go from a ton of data that comes in to a little bit of data. Remember, there's got to be trade-offs somewhere, right? I said the people that we sell to, they want the capabilities that the Fortune 2000 have, but they don't have the people or the money to pay for them. So there's got to be an offset. So what we've figured out is there's a bunch of data that comes into your SIM. Doesn't do you any good. There's no point in keeping it. It's just waste. So we actually throw it away. Yeah, this baby can store so many logs. You know, that it just had to have the meme. I dropped that in Slack one day. People thought I lost my mind. But no, like really, like we were just like shoving logs in there, and I was like, this is it? Like this doing it? So yeah, a lot of stuff. Oh, this is kind of hard to see on here. But so again, this is one of those kind of like anti, right? Usually people are talking about like how big is your cluster? How many queries per second? So here I took a snapshot of just an average day. We were doing somewhere around 190,000 inserts per second. But we were doing it with, you know, 10 to 12 cores, right? Our ClickHouse cluster is actually pretty small. We've got 3 nodes. They're like 10 vCPUs and 40 gigabytes each in terms of memory. In our testing of trying to see like really how far can we push this, I've actually seen inserts just shy of 1 million per second. So this will go very far. And that's at a same size cluster. So obviously when we were doing 1 million per second, we were probably pushing almost 30 cores to the max. But that's on the smaller side of your options in ClickHouse Cloud. Like you can really go up from there. And I haven't had to do it yet, but in theory, you could add more nodes. So you could go from 3 to however many you want and scale horizontally as well. Gives you additional processing capabilities. So it's there if you need it, but ideally don't use it all. So this could go in so many different ways. There's so many really interesting things that we could talk about, whether it's compression or all kinds of different stuff. In putting this talk together, I was struggling a little bit to figure out like, how do I take all of this stuff that's really interesting and fit into 20 minutes? Because there's just so much. So if there's more interest, maybe I come back and do another one. But I tried to put together some lessons that we learned that were really interesting for us in scaling it up. Number 1, partitioning. I've seen a lot of people go wrong here, and I know this because there's a lot of Stack Overflow and forum questions. The first thing they reach for is partitions. They're like, oh, I'm gonna make a bunch of partitions and it'll be great. That's what we did as well. That's a common pattern in Postgres. You add more partitions, you split your data up. When you do a query, it'll figure out what partitions it actually needs to look at, and the ones it doesn't, it won't look at them. So we said, partitions, great. This is what we should do. We split it up. We said, hey, we'll bucket our tenants to like 100 buckets. Each of them will have 1 day. So each partition would be for 1/100th of our partners for 1 day. Very quickly, we ran into this issue where we were trying to insert into too many partitions, and ClickHouse said, no bueno. There is a setting you can increase this. You can have more. You like, so it says like more than 100. That's the default. I've seen people increase it to 1,000, but the problem is it's always there. And we were expecting to continue to grow partners and to have more. So it was always going to be a limitation for us. So we went back. The ClickHouse Slack is actually really useful. And there's a bunch of people. And ultimately, they guided us in the right direction and said, hey, partitioning is really only for pruning data, time to live stuff. So you create a partition so that way when your data ages off, they drop the whole partition. Very quick, you know, and it's super useful. So do it that way. What actually happens under the hood is data will be broken out into a bunch of parts. So you'll get that whole Postgres partitioning automatically for free. So you don't have to worry about it. So this is where a lot of people go wrong. Lesson number 2, you know, this was kind of already talked about, like ordering of your data and your primary key and your sorting key is super important. This is maybe the biggest thing that drives performance in ClickHouse. So, and this is where a lot of people go wrong. I know this is where we went wrong. In Postgres, like you set up the table and you put data in it and you only specify a sorting when you query the data. Postgres puts it on disk however it puts it on disk. In ClickHouse, not so much. You got to tell it, hey, sort it in this way because this is how I'm going to query it. And so you want to query things based on some common identifiers. You also want to have multiple columns. I think the guidance I've seen is usually around 5 sorting columns. And you want to order them based on the lowest cardinality to the highest cardinality. So in the example here, you know, it's accounts to users to the date to the actual timestamp. And the idea is there are fewer accounts than there are users, than there are dates at some point, then there are obviously unique timestamps. And so if you're querying on these, ClickHouse behind the scenes can drop a ton of data. Right? If you only need one account ID, it can say, oh, all of this massive amount of data I don't care about, just this little piece, that's what I care about. And so it can be very fast. Like other people said, fixing this later is a pain in the butt, especially if you want to try to do it with like 0 downtime. But the problem is this one also gets a lot of people. So a lot of people go through that pain. It'd be awesome if we could find a way to fix that, work around that. You can actually change the order by after, but you could only do it by like adding new columns that weren't in the table before. It's a little convoluted. It didn't work for us. Lesson number 3, data skipping indexes aren't magic. So in Postgres, again, where we spent a lot of our time, it was like, hey, if you need to access data in this way very quickly, you add a secondary index and it's like a B tree and it's super fast. And so we were like, oh, sweet, data skipping indexes. That's the same concept, right? No, it's not. It's very similar, but it doesn't perform in the same way. So we threw a secondary index and we ran queries and we used explain and we saw it was using the index and we were like, it's not faster. What the heck? And as we started to dig in, what we found out was that actually the performance problem was that we had to visit a lot of parts to find the data that we needed. So each of those parts had to be pulled in from S3. It will cache them on ClickHouse Cloud, but it only caches so much. And so there was this performance hit that we were getting because we needed a very small amount of data from a lot of parts because we had ordered the data in one way and we're querying it in a different way. So in some cases, these are great, especially if your data is sparse. Like if you need to find a thing in your data that's not super common, these are great because it'll allow ClickHouse to, like, again, skip a bunch of parts. It doesn't have to pull them from S3. It doesn't have to parse them. It doesn't have to iterate. Really great, but just don't assume that you can throw these on and your queries will magically be fast for you. In summary, what are some of the benefits? We talked a lot about them. Other folks have talked about them. Super fast, horizontally scalable. Compression is, how do you say it? Like amazing. We saw 50x compression. on our data. Wild. I had to go check it because I was like looking at the size. There's actually a table you can query in the system tables that will tell you like how much data is there versus how much is on disk actually, and the numbers just seemed way too good to be true. But like when I queried the data, it was all there. It really is. And we actually saw this get significantly better as we adjusted our ordering keys. And the reason for that is we had data locality. So a lot of your data is going to be similar. Think of stuff from the same user. It's going to have the same username. It's going to have the same email address. It's going to have a lot of similar fields. If you order those together, that same pattern can be reduced significantly. That's basically the way compression works, right? Find a pattern, replace a long pattern with a small identifier. We've now reduced the size of the data. So for us, that was huge. Partitioning is awesome, allows us to drop data very quickly. Query like part and granule pruning. If you're not familiar with using explain, get familiar with it. That is how you know how much data it's going to be looking at. That's the first thing you should reach for when your queries are not fast. You want to understand why. And SQL support has been great. Initially, I was a little bit worried because we've looked at some other stuff that, you know, they claim SQL, and then when you dig in, it's like, well, it can do this, but like all of these kinds of queries are not supported. So I was a little bit worried about it, but honestly, we've not run into anything. Everything we've thrown at it in terms of like SQL syntax, whether it's CTEs or anything else, has worked. But it's not all roses. Like some things are hard. So I talked about, you know, secondary data skipping indexes. One of the problems that we have is that we've got two use cases for the same data, right? We have one use case where we want to look at it per tenant over time. And so when we do and we specify tenant ID, it can prune a lot of stuff. It can find that data very quickly. But because of the way we do hunting and security, we want to hunt across all of our clients. So in those cases, we actually want to see all of the data, say for like a given time period. Because of the way the data is stored on disk, ClickHouse has to go fetch a bunch of small pieces from many parts. It makes those queries very slow. Still trying to figure out how exactly we get around this. I think we can use a projection for this to reorder the data. The only downside I'm looking at is then we have to store all of the same data twice, stored in two separate orders. So I don't know. We'll see how that goes. I haven't tried it yet, but that's what I think we're gonna have to do. The lack of a JSON data type, we got super comfortable with this in Postgres with like JSON-B. We could like have a bunch of fields that we knew were very specific, but then if there was like extra data, we could just like throw it in a JSON field. We could easily fetch it. If later we decided we needed that as like a first class column, we could create a column and extract it from all the JSON data with a migration. It was awesome. We are currently doing this in a little bit of a roundabout way. We use maps. We use maps with like string keys, and then each map then has a type. And so that allows us to do different stuff. So we have multiple columns, like one column will store values that are strings, one column stores values that are integers, one column stores values that are Booleans. And we have this whole like logic to figure out like which column we should use for that. It works okay. I've seen Uber has a blog where they talk about doing this. They do it with two arrays instead, where the keys are in one column, values are in another, and they use like index of to figure out like, oh, the value I want is in index 3 in the data. My understanding is maps are effectively doing that under the hood. So maps were just easier for us at the time. And then, you know, the last one is kind of like compared to many other technologies like Postgres or like many of these other things, there weren't a ton of technical blogs, discussions, people talking about like, hey, here's what we've used it for. Part of the reason I wanted to kind of come and give this talk, but this is growing. Like, there are a lot of people now writing blogs, talking about use cases, all that kind of stuff. So getting better. And with that, that's it.